In the future, we'll print our houses.
What?
House printing.
What for?
Let me explain the background. These are the biggest cities in 2007. 4 years ago, a number of 4.5 billion used to live in megacities. That was about the half of mankind. This year, the limit of 7 billion inhabitants will be exceeded. And if prognosis of the United Nations come true, we will be 9.2 billion people in 2050. They want to live in megacities because they promise a better life and wealth. Agglomerations all around the world will grow like never seen before. Imagine, there will be a huge bunch of people who urgently need living spaces. How to solve this problem? This is a great opportunity to rethink our cities. They must become more sustainable, carbon neutral, smart, and of course they should be able to grow fast. For a lot of countries, the solution is to rebuild and expand existing cities. They are already testing new ideas for the future. For example, South Korea, where New Zhongli City is built. Another experiment is Tianjin Eco City in China, or Master City in Abu Dhabi. But these projects are so big that they are tremendously expensive. When a country becomes wealthier, it has the opportunity to build cities from scratch, where the raise of salaries comes along with. At a certain point, the application of machines is more profitable. Therefore, a lot of countries in the world do research on robots that could make the construction of large settlements cheaper. Their basic idea is to use the same methods as in rapid prototyping. For example, take this cup. If you want to print it, a 3D model is developed virtually and then printed in reality by a machine, layer by layer. So far, this research was successful. A prototype of a concrete builder is now able to stack concrete and form dynamic shapes. Even a life-size wall could be printed. This is the actual state of affairs in science. We can call these first trials the first generation of house printers. The following one is the first concept of a house printer that's supposed to print 3D life-size houses outside the laboratory. This study tries to define a completely new kind of machine that's able to produce large settlements in a short period of time. It's not completely autonomous, but works together with skilled craftsmen. So how does it look like if we start to print a house? We still need a lot of construction vehicles, but the most significant one is a house printer called contour crafter. Preparation starts with flattening the required space. In the second step, the excavator creates a trench for the foundation, which is filled with concrete by craftsmen. The contour crafter runs on especially developed rails that avoid it sinking in the mud. The machine is placed on top with a crane. To reach a specific point in the three-dimensional space, a movement on the three axes, x, y, z, is necessary. The rails form the first one. The y-axis is defined by the height when the house printer starts to erect itself. When it's totally erected, it measures 6 meters. This is the equivalent to a two-story house. The last axis is defined by the crossbeam, which connects the two limbs. This is where the printing head is mounted. Here the house printer is completely erected and ready for action. Last thing missing is the raw material. The extremely fast-drying concrete is pumped through a drag chain into a valve at the front of the machine. Here you can see the pipe system with a printing head at its end. At this point, the complete house is produced. It's led by CAM to a certain point in the three-dimensional room. Here the concrete is hardening very fast, so the first layer is a foundation for the following one. This is how it works in detail. Concrete is extruded by a 4-axle nozzle. Therefore it has a bigger moving range. The print head has 3 different openings to shape specific extrusions. Here you can see a load-bearing wall and a standard wall. The nozzle can produce blockouts for the pipework or electricity that's installed in the house finishing state. With these abilities, the first level is printed. The following task is to bridge the window cutout. That's the point where the robotic arm comes into play. It grasps a lintel out of a depot and fits it into the opening. The robotic arms are also responsible for the ceiling installation. It's pre-manufactured and built with the chain-like metal. This structure is rolled up endwise and offers a building area for the next level. The machine's work is finished after preparing the roof structure and craftsmen start to finish the house. This is a proposal how the first printed family house could look like. It's individually fitted to the needs of the customer, but anyhow mass fabricated. So what are the future prospects of this technology? Nowadays at construction sites, concrete is the most used raw material worldwide. The vision in architecture is to print sustainable structures which are made of biodegradable substances, like in nature. They get the maximum of stability and the minimum of weight, like nature produces its creations since millions of years. When the contour crafting technology is more advanced, it could print extraordinary structures never seen before.